Hello, I'm Robert, founder of Doomsday Debunked, and I thought I'd talk through some of my articles, and this time the one about how our generation's children are headed for a world with nature and wonder in it, and their nature too, their children too. It's just so sad the way that people are beginning to think that we're headed for a world without nature. I mean, it's utter nuts really when you come to see it, as we'll go through this article. And just in 2016, in 2017, nobody was even had this on their mind. It's really come in since 2018. And they're panicking and thinking we're not going to manage to do anything about climate change. But last year, 2 years ago, how many of you were even thinking about the Paris Agreement? Not so many. And actually, there's been a huge increase we've made huge progress since 2015. I'm in the UK and we're targeting zero emissions by 2050, and there's mainly a question about how we're going to do it. And there's so much going on in the world already. These 24 ways the world is getting better. I can talk about that all another time. We're only 14 years in. We're only 3 years into the 14 years from 2016 to 2030, and we've already knocked off more than a degree of the projection for 2100, and we've got down to 2.9 degrees C, and we've got to get down to 1.5 degrees C. Admittedly, the rest of it is harder work than the first bit we did, but we can certainly do this. But even the worst case, and it's nothing like what you imagine. There's so much junk science, like the exaggerations and so on. So even the worst case example, we're not looking at the world without nature. This is what the worst case of what happens to the Amazon. Something like this. Here it is, as it's full of all these wonderful animals. After it, then it's going to be rather dry if we go right up to 3 degrees C, and if large parts of the Amazon turn into savanna. They're not going to turn into desert, not permanently. Those brown fields you see, those are just those are immediately after a fire, before it's had time to grow again and regenerate. And this is what eventually you get. In the very worst case, if they were to cut down, and it's not going to just burn down, because the tropical rainforest, as it is very resistant to burning because it's so very wet. It's not like the California fire. It's not like the California forests, where the California forests the trees are adjusted to fires. Some of them only even need fires in order to reproduce, and they have special bark that burns very quickly, and the fire goes through them quickly, and so they don't get badly damaged. But the Amazon rainforest is very different. It's so wet there that the fire just can't start. And if a fire does start on the very edge of it, it only travels through it at 200 to 300 meters a day. And travels along the understory. It's called an understory fire. And they're very easy to put out. And then they will, even if they keep going all the way through the dry season, then they'll go out as soon as the wet season starts. So there's no way that these fires you see in the Amazon are going to burn the entire Amazon down, even if nobody did anything. What these fires are doing, the very fast ones that you see, what they are doing is that the loggers, first of all, early in the year, they fell lots of trees. They leave those trees to dry out. After those trees have dried out, they then burn them. So some of them you see are felled, burning trees. Some of them that you see are actual plantations that are burning. And some of them are just grass fires. So we aren't at any risk of the entire Amazon burning down through fires. And even the deforestation, even if I keep on with that deforestation year after year, we haven't yet reached 20%. And it's going to, and there's loads, there are entire countries of Amazon rainforest, like Suriname, that preserve their entire rainforest throughout the country. And large areas of the rainforest, and that's large areas of the Amazon rainforest in Brazil still remain, and in neighbouring countries. And the western part of it is so wet that and so resistant to climate change that it'll be there no matter what happens right through to 2100. Unless, of course, they fell it down. But they're not going to do that anytime soon. And so and then there's this idea of a tipping point in the Amazon. But this has been rather discredited. There is some research early on, but they use just 2 kinds of plant species, and nothing about nutrients, and very, very little in it that really, very, very sparse, very primitive models that came to these conclusions. And as they've got more complex and looked at more details, and they find there's a lot of biodiversity, many ages of trees and so on, it's much more like a slow patchwork effect. In other words, it's not going to happen instantly in 1 year or 5 years or something, but over a period of decades, and gradually, this is the picture that is emerging, then gradually it could transform from the rainforest to something like this savanna effect through the combination of the logging and the drying out and the effect of the dry conditions on the rainforest. Even that is not certain, because as it gets warmer, it depends very much on the way the forest responds to the CO2 fertilization effect, because it being more fertile helps it to be more resistant to this. But anyway, in the worst case, then this is what's going to happen to the Amazon, that it turns from a forest to savanna, and savanna with lots of bushes and occasional trees here and there. That's the very worst case in the Amazon. It's not a world without and these are some of the animals you see. You see, like this animal sadly would be gone, but these things are still here, and that parrot will still be there afterwards. It occurs in both habitats. And even today, there are many initiatives to restore the Amazon, and for instance along the rivers and such like. You can preserve the Amazon rainforest along the rivers. You can have you can actually improve the productivity of the cattle ranches with more cattle on less land. They are actually much less efficient than they are in other places of the world. And so just by increasing the productivity of the cattle ranches in the Amazon, then I think that's through to 2040 or so, they can deal with the increase in demand just by doing that, if they can shift around to doing that rather than cutting down the trees. And then they can also grow valuable economic timbers. And I talk about all that in my Amazon rainforest article. So there's actually a lot of hope in the Amazon. They need to turn it around, and they can sustain all the local people and the increase in what they wish to have increased productivity naturally. They can do it by shifting how they do it from this constantly cutting down rainforest every year to becoming more efficient, and then replanting and restoring the rainforest along the rivers and various places which is not so easy to ranch. So this is a future that we can expect. And what you need to bear in mind when you think about the Amazon, well, where I live in the UK, we used to be completely covered in forest over the entire UK. And the UK is the end result of thousands of years of people cutting down forest and burning forest and putting sheep on the hills, and the sheep eat the forest. And the mountains, the rather splendid mountains that we have, they would have been covered in trees soon after last. They were covered in ice originally, completely covered in ice. The whole of the UK was covered in ice. There were no trees at all. And then after the last ice age, it became tundra. And then after it became tundra, it then turned into trees. And then after that, then most of the trees were cut down, and there's only a few remnants of the forest left. And it then became what you see now, which is lots of heathland and grassland and lots of sheep. So landscapes do go through these changes. And of course, we can't restore the old forest that we have here in the UK, but it's a very diverse landscape that we have. All the different human things, like the ancient water meadows and the coppice woodland, and even things like our houses, where various creatures like birds of prey and pigeons and things live, and the bird feeders, and nest boxes and so on, and little niches in houses and in quarries, for instance. The habitats in quarries where you get rare creatures that don't occur. You have grasslands where sheep graze and so on. So if you have humans doing it patch by patch into a forest, they can actually increase the diversity. Now, this doesn't really work in the Amazon. The main Amazon rainforest is so biodiverse. Every little square meter almost, well, square hectare or something, is a little bit different. So it's the most diverse habitat that we have on the planet, and it really is very sad to lose any of it. So the Amazon is a little bit different from Europe in that respect, but it's still going to be a wonderful place with lots of nature, no matter what we do. And even if humans were to cut down nearly all the Amazon rainforest, as they did in Europe, it would still be a wonderful place for our children to live in. And we're not talking about a world without nature. And this is in Scotland where I live. This is my sister's meadow. You see all the wildflowers there, and this is actually the end result of all that cutting down of trees that I talked about. And now we have sheep, and we have all these wildflowers. These wildflowers, they wouldn't be there without the sheep that are grazing the grass, or something cutting it, or human beings cutting it, and so on. And we are not going to this is not going to turn into a desert no matter what. It is very damp where I live. It's sometimes called a temperate rainforest because we get so much water. I think it's 2 meters a year, something like that. If I go and put out a dustbin and I leave it open for several months, it can fill almost the top with water if you don't put a lid on it. That's how much water we get here. And that's not going to change. It's going to be dry in the summer but wetter in the winter. And we are actually in northern latitudes like the UK. We have a longer growing season, wetter in winter, so long as we handle the drier conditions in heat waves in the summer properly. Then we have a longer growing season. We have more productive crops, and this continues way into the future. In the tropical regions, then it levels off, but they're not quite sure when, because of the CO2 fertilizing effect is the main reason that they are still having increasing productivity in the tropics, and that's going to continue for a while. But after a while, then it's going to level off because of all the drought and things like that, and then it's going to actually diminish. But we can adapt and make it much less of a problem in the tropics as well. There's no doubt at all that by far the most economic, the safest, the best way to do it is to cut emissions to zero quickly. And by quickly, I mean 2050. Don't listen to the Extinction Rebellion people. 2025 is not necessary. It's great if we can do it quicker, but we have to do it in a way that is consistent with preserving biodiversity. Rush through a program of carbon zero by 2025, and you could end up with a place with trees planted willy-nilly everywhere, biodiversity severely harmed, nature services not working very well, just in order to get rid of the CO2, and lots of machines and things that aren't really working because they're not properly planned. We have to do this properly. And we have plenty of time to do it properly, and we're not headed for a world without nature. Before 2050 is great, 2050 is brilliant, and if we overshoot, we can still bring it back, but that's much harder. But even the difference from 1.5, even at 3 degrees C, we're still talking about a world with lots of nature, very habitable. We can grow food for everyone at 3 degrees C. We have there's no problem with food security as long as we are careful. If we do it, but we are headed for 2.9 degrees C, and we're likely to get well below that. So I'm sure that we're going to increase our pledges with 2020. We have 2035, 25, we have 2030. We have many opportunities to improve on where we are at the present. And but if we are unlucky, and if we are it is possible. There's a range of values. They can't say exactly where we're going to head with different carbon dioxide levels, and it's also maybe we don't pull together and we don't manage to get it down to below 2 degrees C in time. Then the one main thing that's going to happen at that point in terms of ecosystem is we lose the coral reefs. But this is what happens to a coral reef. It turns into...
Coming up next on Jonathan...
I'll mute it just so you can see while we're talking. So you can see this is a sponge reef. And I mean, it looks pretty wonderful. Yes, let's look a bit more. It looks pretty wonderful place. It's quite diverse, but it's not nearly as biodiverse as a normal coral reef, sadly. But it's very much like going from there to there with the corals. You're not talking about a desert. You're talking about a wonderfully biodiverse habitat like the Amazon rainforest, turning to something that's not so diverse, the sponges, which are a little bit like the savanna in terms of biodiversity, not so productive, not so much life there, but it's still got an awful lot compared with, it's still very biodiverse. So that's what we're talking about there. And we do not have insects they do not go extinct on any scenario. This is just nuts. That was a rather ridiculous paper. You see, this is the map that they did, and look at most of the map is completely white, and this dot here and there, that is the domestic honeybee. That's rather like looking at biodiversity of animals and counting sheep or pigs. It's ridiculous. They shouldn't have done that. They shouldn't have included those. And they did a search for declined star. So we're obviously going to turn up declining populations. And some of these are just completely wrong. For instance, the Puerto Rican study was, they got researchers who originally announced that they're destroying, this is one of the first ones, the Puerto Rican rainforest is not going to have any insects left there when they're rapidly disappearing. What it turned out was that the early data that they had was of insects, that they found lots of them because it was immediately after a hurricane, which knocks down lots of trees, creates lots of gaps in the rainforest. And then you get lots of insects in the gaps, and they're easy to see, and there are loads of them because of all these gaps that insects like. And then after that, they looked at it later, after the forest had regained its, all the trees had regrown again since the hurricane, and they saw much fewer insects. And so they went and wrote this study saying all the insects are disappearing from Puerto Rico. It was completely wrong. And none of the, I don't think any of the articles that have said this have published this other paper that showed they got it wrong. So there you are, you got these titles: Insect Collapse, we're destroying our life support systems, and the insect apocalypse is here, New York Times. And it's just a mistake. And then this is the one that led to people saying we'd have no insects within 40 years. And it's absolute nuts. It really is nuts, the idea that we could have a world without insects. I mean, look at this. This is, and I've got to turn off the sound again. Where I live, you have these midges. It's a tiny, biting, very nuisancey things. And on the worst days, then it doesn't get as bad as this where I am, but I am pretty bad, pretty midgy where I am. Look at this, all the midges just blowing up in the air. And we're not going to some people in Scotland would wish we could end up in a world without midges, but no, we're not going to end up with a world without midges. And not without the domestic bees either, because they're very easy. This shows how you can split a hive. And it's just like sheep, you can have as many hives as you like. And this is from the Food and Agriculture Organization, how the numbers of beehives have increased from 66 million in 1994 to 90 billion in 2017. And it's reasonably steady in the US. So when you get people saying that we're a bee apocalypse and we're losing all our bees, that's nuts. We're not. I mean, just look at those figures. They're just spinning it out of nothing. We did have problems of bee collapse disorder, but because it's a domestic insect, you could cope with that by just duplicating the hives to replace the gaps. And so we've had steady amounts of We haven't even had any reduction in, we've had just a steady increase in beehives. And then there are many measures that people are taking to help with the bees. What does matter, not the actual numbers of bees, we can always have plenty of bees. What does matter a bit is the biodiversity of the bees. If you have a mixture of wild bees along with your honeybees, then that diversity gives you somewhat better crop yields. So that is important. And there are many measures being taken to help make sure that we do that. And then also, these are the stingless bees of Malaysia, and they also produce, and they also are able, they also are now using them to produce honey, which is, they produce less honey, but they still do produce honey, and they're useful for that. And Germany, which is one of the early ones, they've started up their program. They've got a new action program. In that case, it wasn't because of global warming, it was because of insecticides. You expect, or probably, and being used on crops. At least that's one likely factor. And you expect a place like where I live in the UK, as it gets warmer, we're going to have more insects, not fewer. It's not likely to have fewer insects when it gets warmer, because insects just love warmth. They love warmth as long as it's moist as well, then you're going to get more insects. But for the biodiversity, you can help this. You can make yourself a little bug hotel, and so that's about that. And then this is about how actually so far the land is getting greener, not browner, worldwide. India is a real hotspot because they have learned to grow more than several crops a year, and they use drip feed agriculture, a very efficient form of agriculture. Meanwhile, China, it's getting a lot greener because it's doing a lot of restoring of desert back to forest and agricultural land. They've got huge restoration projects in China. And then the rest of the world, most of it is naturally getting greener because of this CO2 fertilization effect. And this is trending in leaf area over the world. There's one way of measuring it from orbit. And this is one of the Chinese projects that I told you about. And this shows that you never give up. It's a bit like that thing, like that silly, the silly one I'm rather fond of, what's it called again? But their catchphrase is never give up, never surrender, a spoof of Star Trek. But it's like that. You never need to give up, even on a desert. This is a desert, almost desert, the Loess Patlu. It's about the size of Belgium. And this is what it was like before. And this is what it turned to. That was 1995, and that was it in 2009. Look at the change. And you can do that everywhere. I have a whole series of, if you go to my 24 ways we're improving, you can find a whole series of ways that this is being done. And recently we had the Ethiopians. They have done the same sort of thing in Ethiopia. And they recently had a project to grow, they planted I think 1 million trees in a single day in Ethiopia. We could do that in the UK, but for some reason we're not. But in the UK, we're doing some replanting, but nowhere like the way they're doing it in Ethiopia. And this is about what happens as you warm up. Notice, this is in 2001-5. Now if we were to warm up to, I'm not quite sure what it is, I think it's a 3 degrees rise. Does it say? Anyway, if you warm up, no, I think that's a higher degrees rise. Why didn't I write it in my article? I'll check that after this. I'll bring it up. I think it says in the link to article. Wait a minute. Growing degree days. Oh, I never figured out what it was. I think it might be business as usual, but it's a very techy paper. If any of you know, then do let me know what the paper actually means. I'm not sure if I think it might be business as usual, which we're not actually on. So this would be like a very worst case. It's not going to go as much as that. But if it got as warm as this, then all those areas would open up to conventional agriculture, small cereal crops, such as barley and oat. Between there and there, it's a vast area that would open up. And this shows, this is another one, it shows the band of, this shows the expanding bands that you get. Anyway, so as the climate warms up, we are going to get better agriculture in the northern hemisphere and upper latitudes, but it's going to eventually plateau in the tropical areas, and then eventually it's going to lower a bit. So what is happening, that our population is increasing, and as it's increasing, actually our agricultural yields are increasing because of the CO2 fertilization effect. And the main risk is it going to continue? Luckily our population is going to level off. Somewhere between 2050 and 2100, we have already reached peak child. We're not going to have any more children, almost, just going up very, very slightly. We're going to have the same number of children probably in 2100 as we have now, or probably less. And the population is growing because we are living longer. And in Africa, then the African population is growing, and it's probably going in the worst case of the world population division is something like from 1 billion to 4 billion in Africa. But it's also the area of the world that has the most inefficient agriculture. They can improve much of their agriculture tenfold in yield. It's very, very low productivity, because if they were to become as good as China and the USA, then that's a tenfold increase that they are capable of in sub-Saharan Africa. The reason is that in the 1950s through to the 60s, we had what's called the Green Revolution, and this developed new strains of rice and new forms of agriculture and new strains of everything that managed to produce far, far more food from the same area. And this is credited with saving the lives of billions of people who would have starved of famine and starvation, died of starvation, if it wasn't for the Green Revolution. And this continues to this day. Every year we have new varieties of rice and other cereals that are developed, and they develop to the new conditions that they're developing there, and they come out every year. Cereals particularly are very, very well researched and worked on. But the things that you grow in sub-Saharan Africa, cassava and stuff, they just haven't done it for that. And so they just never got around to extending the Green Revolution in the same way to sub-Saharan Africa. And the new forms of agriculture and the irrigation and everything, doing that alone will make a huge difference to how easily we can feed people by 2100. Sub-Saharan Africa is the key. Most of the rest of the world, the population won't change. There'll be hardly any change in the rest of the world apart from Africa through to 2100. In some places it is already decreasing, like Japan. China will increase for a while till about 2050 and then decrease because of its one-child policy, which means it's going to be actually quite difficult for it to maintain its population through to 2100. India, I think, is a bit of an increase, but most of the increase is in sub-Saharan Africa, which is the very place which has the greatest potential for an increase in agriculture. So you don't need to worry too much about this thing, about how in the tropical areas eventually the crop yields are going to plateau and then start decreasing. At 3 degrees C you would get these decreases, but we might actually be able to deal with that, because that's not taking into account of new varieties and new approaches, new forms of agriculture and new crops, that the many new ideas for crops that can be either cultivated. There's also a possibility with care doing genetic modification of crops. For instance, maize has a much more efficient form of agriculture, of photosynthesis for very warm conditions than rice has. If you could move the genes of maize into rice, rice could be much more productive. So in the hot conditions, it's particularly genes that are very good for hot conditions. There's a project to try to do that. It might take a decade or two, but they have done some of the first genes that can be, some genes have already been moved over, not necessarily directly from maize, but it's called C4 photosynthesis, which has arisen many times independently, and they think that using genes that are within rice and copying ideas from maize and some importing genes, that they may be able to make rice have C4 photosynthesis and so have larger yields and be better adapted for a warmer world. So this whole thing about reducing yields in a warmer world, we don't know for sure. And so there's a lot of potential, but there are plenty of things that go wrong in a warmer world. We don't want to do it, if we did it over, say, 5 centuries, I think there's absolutely no doubt at all a warmer world would be, if anything, far more habitable for humans, with us adapting to better ways of using the tropics and all these extended regions for crops in the northern latitudes. It's the question of how quickly can we do it in can we adapt. It was the same for the coral. If you go back to the corals, I just go up to it again. That was the corals, which is you get to see what I watch in my spare time. The sponges sometimes. Anyway, I can't find the corals now. But I just only had sponges. But the corals also, they may well be able to adapt. So it's like the precautionary principle. They're looking at what could happen. We have to be ready for a world in which 99% of the corals are gone by 2050 or so, or 40 even, if we get to 2 degrees C. But it is possible that it manages to adapt, because there's some corals, some branching corals, even in the Great Barrier Reef in Australia, are able to withstand the temperatures changes already in the coral reefs themselves. Also, we have coral reefs. We have corals in one reef that are a degree or two warmer than the coral in another reef. This means that if those reefs, it's just they're in the wrong place. If they were in the other place, they'd be able to survive. But we can't actually move an entire reef. We can move individual coral plants, but it's just not practical to move an entire reef, 100 kilometers or 1,000 kilometers or whatever it is, to a place where the temperature would be just right for it. So that's the problem with coral reefs. It's the very few that would actually reach temperatures. I mean, the ones at the highest temperatures, I include the Red Sea. They're at a very high temperature, but they are adapted to even higher than they have, and they're amongst the ones that are most likely to survive. So it's not really an absolute temperature. It's more like the corals are used to such stable conditions that where they are, then an increase by a fraction of a degree can mean that they all start dying. But only the ones there would die in those conditions. Ones in warmer conditions would do just fine. This is a subtlety that's not always explained with coral reefs. So we don't actually know for sure that they will, that these large numbers will disappear at 2 degrees C. It is possible that they adapt, but you don't want to take that chance when there are hundreds of millions of people. I think, I don't know. I don't think it's as many as a billion, but I think it might be hundreds of millions of people who depend on the coral reefs, and they're such wonderful things like the rainforest, such biodiverse places. We don't want to take that risk, and it is a very significant risk for the corals. But they are the only ecosystem that has this huge risk. Now let's go down a bit. Okay, so now, so then there's the idea that people have that we're going to have a world without kangaroos. We're not going to have a world without kangaroos. We're not going to have a world without humpback whales. They've actually increased. I think some populations of humpback whales are already back at the population they had before whaling. So we've got wonderful recovery of most of the species of whales. we're going to have whales through to 2100. We're also going to have polar bears, and no, we're also going to have giant pandas. Came out with the wrong word. And we're going to have not just we could be. I've got my. I'll do my extinction one another time. It's a separate one, but and we are not at any risk of extinction. We are increasing. We are able to live in grassland, artificial habitats, of course, forest, shrubland, desert, rocky areas. That's not even counting the like ice, the Eskimos and the ice fields, and the tundra, and we can live almost anywhere. We're not going to go extinct. There's absolutely no possibility. We're a species of least concern. So, and all the we're not looking at a world without gardens and without flowers. That's impossible. Indeed for plants generally, then seeds are very easy to preserve, most of them. Some tropical seeds, like mangoes, you can't preserve. And if you want to continue to have mangoes through to 2100, we'll have to keep planting mango trees. There's no other way of doing it. But because the mango seed itself can't be preserved at present. But most seeds can be preserved, and we revive seeds from thousands of years ago. So, and we have huge seed vaults. We have the seed vault in Norway. There's a big seed vault being built in the UK, organised I think by the Kew Gardens, I'm not sure. The Kew Gardens, of course, there are lots of seeds, and then they have a seed collection. And it might be other people. There's a whole separate new, very big seed vault being preserved. It's going to produce just that one alone will have a large percentage of the seeds in the world. And all our crops, and numerous varieties of every crop, are now preserved in seeds already. So there's no way that we're looking for a future without these, because no matter what happens, those seeds are there, and we can just go and get them out of the seed vault and grow them again. Sadly, there are a fair number of plants you can't do that to, but we're not talking about a plant world without those. And then gardens. You can have a garden on the moon. There's no way that we're going to have a world with our designs that you can use, pressurized greenhouse and everything. There's no way we're going to have a world without gardens and insects and flowers and all the sheep and so on. Now, the extinctions that we do have, then if we run this, and this shows how, let's switch off the sound again, then it shows how the is going backwards in it's going backwards in time to when the world was one supercontinent. And so in the time since then all the continents have separated, and they've gone a different way, and there you go, Antarctica coming back up here. Oh, wait a minute. No, that's into the future, sorry. I got it back to front. Yes, of course, Australia is banging into China in the future. And so in the future, all the continents are going to collide together. I was getting mixed up. I knew it was wrong because I thought India wasn't. India crashed into Asia to make the Himalayas. In the future, Australia is going to crash into China and presumably make a big mountains chain when it does that. But this is very, very slowly over. That's going to take 300 million years in the future. So then, at the moment, it's sometimes the world consists of continents altogether, like Pangaea, way back. But then that's what I thought it was going backwards in time, but I just wasn't looking very closely. So back in time we had Pangaea, and that was one big continent, and then now we're all separate continents. So we have different ecosystems and whole different biospheres in Australia, in Africa. None of them, those animals, most of the animals, the birds of course, some of them have flown all over the world. We have the Arctic terns which fly from one pole to the other every year and back again. But many birds are local too, and a lot of the animals, of course, they find it very difficult to get across an ocean. So we have these completely different ecosystems in South America, North America, Africa, Australia, Malaysia, India, China, many species in those that aren't there, and Europe. Particularly the ones that separate as separate continents with almost no communication. And particularly all the marsupials in Australia and the anteaters and so on in the Americas that have just never had any contact between the two. So what we're doing now as human beings is we're going around and we're moving animals from there to there and there, moving animals, rabbits from the UK to Australia and so on. This is very much like what's going to happen in the future, 300 million years. We are artificially colliding the species without colliding the continents. And so sometime in the future, if we hadn't done it, then this future collision will mix together Australia and Chinese species that never encountered them before. But as a result of that, you actually end up with a richer ecosystem by mixing the two continents' species together. And Chris Thomas has got this interesting discussion here about how this is a good analogy of most of what's going on now. It's like merging the continents together. So this is what we face in our future. Worst case is we won't have any major ecosystems go extinct except perhaps the corals at 2 degrees C. And even at 3 degrees C, it's not really a major ecosystem going extinct. We'll certainly have loads of trees and loads of higher animals, loads of insects. And even locally, your ecosystem, wherever you live, is quite likely to become more biodiverse rather than less. It depends, unless you, for instance, are in the Amazon rainforest and it turns into savanna, of course that's less biodiverse. But many places, and looking at the countries as a whole, as long as you have patches of, then if you look at countries as a whole, then the whole country is going to become more biodiverse with all these mixing of different habitats. So species from other places and also the humans, as they do the developing, and they create, like we did already in the UK with our quarries and our meadows and so on, then this is happening around the world, that you actually get in some ways more biodiversity as a result of the collision and as a result of the human created habitats, as long as it doesn't go too far. And you would hardly notice what we're doing a few million years from now if you look at the fossil record. So, and that's a little bit about how we're managing to transfer corals into warmer, how we might be able to avert coral extinction I was talking about. I'm not sure, do I want to go on about this? We've talked a lot about this before. You can read this all. I think I've talked about the main things. It's been absolutely clear now, and maybe I can talk about a bit more about the extinction thing there. If you hear all these things about we're in the middle of a 6th mass extinction, you could try and think about there. The fastest, the species going most extinct most quickly of amphibians, birds, and mammals, animals, are the amphibians, like the frogs. So try and think, how fast do you think that is? What they're talking about is a mass extinction. Talk about how quickly species are going extinct. Oh, we're in the middle of a mass extinction. Everything's going to go extinct. Look how quickly frogs and other amphibians are going extinct. How quickly is that? I'll just give you a few seconds in case you don't know. It's 2% a century. That's the pace. Now that is very fast, according to geological times. That is mass extinction rate. That is a mass extinction kind of rate of change, of extinction. If apart from the very abrupt ones like an asteroid impact, but most mass extinctions, then 2% is you're right in the middle of one of them. But it's not going to mean that we have significantly fewer species of frogs by 2100. And when you talk about species being vulnerable, in the extinction list, I think more than a quarter of them are vulnerable. That includes species that have a 10% chance of going extinct by 2100. It also includes ones with a very small population that is actually increasing. But if it's small enough, then it's still going to count. That's even going to count as, I think even if it's very small but increasing, it's still going to count. I think even it's threatened. It might be much higher than vulnerable. Even as, I got it to, even as, oh, I get this all mixed up. Debunked in the middle of 6, I've got threatened, and they have these two words, they're very confusing. Threatened, I get them mixed up actually. I have to check them up each time. Yeah, threatened is the very weak one. That doesn't mean they meet extinction. And the other one is endangered. So threatened is, if you hear someone saying, this species is threatened, it doesn't mean very much. It's sad, but it means a slight risk. There may be a 10% risk of it becoming extinct by 2100, but it may be perfectly okay, but just a very small population. That also counts. If you look at, if you go down and look at the category, there we are. Where are we? Threatened. See if we can find where to define endangered. Where do I define it? It's about I'll do that another day. But it's a few thousand, I think, that makes it endangered, and threatened is a larger number than that. I'll talk about that another day. But so what was I talking about? So it's this collision of species. Then we're talking about even through to 2100. We're not talking about large. We're not talking about large fractions of all species going extinct. We're not even talking about 27%. It's a much smaller number than that. Oh yes, I did see that. That was quite useful. This the threatened one is, I think, it's 20 years. So if I do that, that's what I searched for before. There we are. That's the thing. So these red ones are the ones that are more endangered. Those are the ones that are endangered. EN. Yes, the orange is endangered and red is critically endangered. And the critically endangered are the ones that are very much at do have a significant risk, but they're not necessarily going to go extinct either. So if you look, for instance, at birds, then nearly all birds are of least concern. Then some are near threatened, and then it's only then after that that you start getting these ones that are vulnerable, which is the 10% by 2100. And then, of course it's sad if any species goes extinct. I'm not saying anything about that, but we're not talking about a future without birds. We're not talking about a future without mammals. We're not talking about a future without reptiles. We're not talking about a future without any of these things. They've all got these big green things. And even the red ones, and many of those, there will be conservation efforts. There'll be a small population that is being looked after very well. And some of them aren't, but an awful lot of them are. So this idea that we're talking about a world without nature, it's not true. And I think that is where I should end this, so it'll go on for a long time. 50 minutes, I see.